Good day, I am Derrick Hogan here with North Georgia Technical College. I've got a little something for you today, and we're going to take a little test and see what is quicker. Can you program conversationally on the machine quicker, or is it quicker to program on the CAD system and the CAM system and go about generating the program that way? Now what we got here is a little simple little part. It's a C-clamp frame. Well, what I'm going to have to do with this C-clamp frame is go about creating the geometry to begin with. So I haven't got the geometry. All I was given was the blueprint here. So if I want to program this on a CAD CAM system, the first thing I gotta do is draw it up. So let's go there and start doing this right here. Okay, what I'm going to do is go about duplicating this drawing here. And I'm going to try to keep my time on this right here. So I'm starting this right now, and it is 3:13 in the afternoon. I want to see how long it takes to do this completely, program this completely. Okay, first thing I'm going to do is I'm going to split my screen here so I can actually have these two things up at once. And then the second thing I'm going to do is go about drawing my drawing, trying to give myself a fair chance here. So let's see, let's pull this over just a little bit more. Okay, so now what I'm going to do is go about creating this right here. If you look down in this area right here, I have this shape here that I need to go about creating here. And it's going to need certain dimensions on it. So let's go about starting my drawing here. So I'm going to draw my first line going across here, and I'm going to go back in a minute and dimension these. I'm just drawing these for right now. In here, like I said, they're not two-dimension. That doesn't matter right now at this point in time. It's just kind of getting my basic outline of my shape here. Once I get the basic outline of the shape, I can go about dimensioning it from there. Now, if I look at this right here, let's see, go full screen here for a second. I have a 2.5 dimension here in the width, I have 3.5 here. So that's going to be my first two dimensions I'm going to try to pull here. So I'm going to go 3.5 here, and I'm going to go 2.5 here. As you can see, because of the fact I didn't dimension stuff before I started, I got a little weirdness down here at the bottom, but that's okay, I can fix that. Here all it takes is a quick little pull of this right here. Now it's looking a little bit more like it's supposed to. Now the other thing I've got is these outer shapes here are 5/8. So I'm going to go ahead and mention that. 0.625 right there, 0.625 right here, 0.625 right here. Once again, I got to fix a little bit of my drawing here. Drag this over. This right here on the end is 1/4 inch right there, okay, and a 1/4 inch there. So let's see, let's go to 1/4 inch right here, 0.25, and then I have a dimension I need right here of 1.5. And I got this right here and this right here are not in the same plane anymore, so I can fix that by making a collinear relationship here. So if you see right here, you got the collinear. And if I click on this and I click on this, I should be able to put those two in the same plane. So now I've got the basic outline of the piece. Now it also has some radiuses on it. I've got a 1/4 inch radius here and a 1/4 inch radius here on the outside here. So let's go by adding those radiuses in there. Use my fillet tool. Gonna make it 0.25 right there. Gotta re-up my fillet tool. And I'm gonna do the same thing on the sides here. And right here also. And now I have the basic outline of my part drawn. So the basic profile is not that bad to get drawn. I have spent about 4 minutes working on it so far. So I'm 4 minutes in and I already have the basic profile. Now I'm going to go ahead and go about creating the actual 3D model here also. Now if I go back to, let's see, wrong browser there, I've got 5/8 of an inch right there. So my depth is 5/8 on this right here. So I'm going to go click on this right here, go to solid, click extrusion, and we'll make this right here 5/8. Let's go -0.625. And I've got one radius that's missing right here, so let's go back and add that radius back in there. Missed one when I was doing the fill tool. So that's going to be a 1/4 inch also on this one right here, 0.25. Okay. So now I've got the basic outline of shape. This is really all I need to do the program on this. I don't need the whole and or anything else with that. So I'm at 4 minutes. And let's see about the program here. So I'm going to save this right here. I'm going to save this as C-clamp. And this right here is a relatively simple project. You know, the more complex this gets, the more you may see an advantage swing to one side or the other. But in the case of this right here, this is not a super complex project here. I'm going to go to manufacture. And I'm going to go about using my manufacturer space. I'm done with the drawing for right now. Okay, now I'm going to, first thing I want to do is go about doing my setup. Click my setup here, click on new setup, and I go about picking what my operation is going to be, in this case milling. Take a look at my model orientation. It's off the center there. That's good there. That works for me. I'm going to go with that. That works great. I could change my orientation, my axes. I could change my orientation and my origin to be like, you know, the model origin or a selected point on the piece or the model box points there if I want to work off of a different corner or something like that. I'm going to work off the center on this. I like probing. Well, I like working off center, especially when I'm probing, because it allows me to basically do a probe like a widths of a part, lengths of a part, and be able to find the center of it. And it's going to take equal amounts off every side, so you know it's going to clean up in that regard. There. Next one is my stock. Now I'm going to make this out of 3/4 by, let's make it 3 5/8, 3.625 by 2 1/4 there. That's fine for that. And my Z heights I'm going to make to 1 inch there. So I'm going to use 1 inch for my Z in this case right here. And my Z is going to be from the offset from the top right here. And it's going to have an offset mount. I'm just going to give myself 50 thousandths. That way I have a little bit of material to take off the top of this piece right here. So now if I look at this right here, look at my piece right here, you'll see a couple things here. Now let's change one thing here. I'm going to go back over here to my stock box point here. That's going to be on the top surface there. Now I could do it on the model box point. Either way works. It just all comes down to how you want to probe it in that regard. So I'm going to do a stock box point here in this. And I'm going to change my material thickness here to not be ½ inch. I'm going to change it to be 1 inch. I'm going to change it to be 0.75 in that regard. It leaves a little bit less material. So the model, I'm going to select right here, click here on that. I'm going to select the thing here, and there we go. So that's our setup. So now I'm at 8 minutes so far, and I have not even started the toolpath yet. Okay, first thing I want to do is I want to face off the top. So I'm going to click on my face tool. Come here, select the top of select my tool here. Let's see, I have created libraries for these different machines that we've got here. So let's pull this over here so you can see it. Go to my local libraries, and I've got one for a Haas VF2 SS that we have, and I've also got one for the Mazak VC300A. I'm going to be doing running this one on the VF2. I'm going to be running a separate one on the VC300. So this one here I'm going to do with the VF2. I'm going to select my face mill right here, which I have programmed the speeds. These is by the manufacturer of the cutting tool. This is actually going to be good acceptable numbers for it right there, so that'll work well for that. I'm going to select my tool here, select my geometry, which is right there. That's fine with that. Heights, bottom heights is my model top there, so that's good there. Passes, I can do both ways. I can do climb versus conventional. I'm going to do both ways here, and I'm going to do multiple depths because I'm going to do 2 passes here. My maximum step down to 40 thousandths, which will give me 1 pass at 40, 1 pass at 10 there. So that will work there for that. And you should see here 2 passes. Actually, I'll just change that there. I want to do one thing different here. I want to turn finishing step on, and I want to do a finishing step of 0.01. There we go. That's more like it. So if I verify this, and I'll simulate this right here, you'll see how it's going to go about taking off the outside, well, heights of the workpiece. By the way, one thing I liked in here, in the verification process, you have comparison. And comparison is kind of cool because what it does is allow you to see how it is, whether or not you have material left over. So if you see green, it's good. If you see blue, there's still material. If you see red, there's a gouge. So that's actually makes it really easy to see where you have material that you need to take off. Next, I'm going to do a 2D adaptive pass on this right here. I'm going to select my tool. It's not going to be that big tool there. It's going to be go back to my VF2 again, my library for my VF2. I'm going to use this 1/2" flat end mill. And it's currently programmed for running with aluminum. So I'm going to copy this tool here. So I'm going to copy the tool here, and I'm going to paste it back in there again. And I'm going to change this one of these right here to be for running with steel, not running aluminum here. So description 1/2" flat, 1/2" flat end mill, low carbon. So this is going to give me one that would have the correct information for that. Okay, it is a 2 flute here, so I'm actually going to change that out for a 4 flute there. I'm going to change my post processor. I'll leave it the same for right now. And my cutting data, I'll just make sure I change that on the machine. I'm going to go about 300 surface feet on this right here. That's 3,300. And I'm going to go, let's go about 400 actually. And I'm going to go with chip feed per tooth of about 1,000 here. Let's go 2. Lead in feed, let's go 24 for that. 24 here, 24 here. Now plunge here, I don't want that to be 55, I want it to be probably about 12 inches per minute there. Okay, click accept on that. I'm good to go. So now I've got one for low carbon. So that's going to be the one I'm going to be using for this. My geometry, I want to select my piece right there. And it's going to take a look and see where there's material on my piece to take off. My heights, I want to have it go a little bit past the bottom. So it's going to be from my selected contour. I'm going to go down about an extra 10 thousandths or so. That allows it to cut past where it's going to be. So that when I go to finish this out, I'll have that clean surface on the other side. Go to my passes here, stock to lead. I want to leave no stock on this. Turn smoothing on so it gives it a little bit more consistent finish there. And if you notice that there is no finishing pass, I am going to turn stock to lead back on, but I'm only going to leave it on my radial, not my axial. I'm not putting my axial because I'm leaving no, there's this piece right here is gone. Once it gets the other side gets machined on this. Leave myself about 10 thousandths for a finishing pass here. So now I've got my program passes to cut that in. A couple things I didn't do. I didn't adjust my step over, so let's look at it real quick. If I look at my step over here, I got optimal load of 100 thousandths. I'm going to get about 10% of my cutter here, so I'm going to about 50 thousandths on this. And there is this roughed out. Next thing I'm going to do is I'm going to do a 2D, and I'm going to do a 2D contour pass. I'm going to use the same tool in this situation. Same data there that you see. And I'm going to select my contour of my part here, the outside surface. Now, Because I'm not machining the ends of this, I could do something like this. I could break my chain up here and not, chain the entire piece. So I could leave it like an open contour here, and I could go about selecting the surfaces I wanted to machine, and then go about machining just those surfaces there. That would work, but really honestly, it would only take a second to machine around this whole piece here, and it may cut a little bit from where the piece, is just a little bit oversized or something like that. So I'm just going to go ahead and have it go all the way around here. I'm going to have no stock to leave. I'm going to turn smoothing on once again, which is going to give it a little bit better finish and a little bit smoother arcs and transitions there. And I've got this roughed out. Okay, so now I've got it set up. It's going to deck the top. It's going to mill this out right here, and it's going to cut that off. Next thing I want to do, if I do want to cut a chamfer on this piece, I'm going to cut about a 30 thousandths chamfer. I'm going to use my 2D chamfer tool here. I'm going to select this top surface here. Select my tool, which is going to be this again in my VF2 library here, and I want to find my chamfer tool here. Once again, it has data for aluminum here, so I'm going to make a copy of this. I'll paste it in here, and I'm going to, or I could do duplicate tool, will do the same thing there. Click edit on this one right here, chamfer tool, low carbon, and I'm going to change some of the data here for it. Let's see, cutting data here. I do not want to run it at 12,000 RPM here, so I'm going to run it about 400 surface feet per minute once again, about 4,400. And I want to run about 2,000 feet per tooth on this. And adjust all these right here down, 24, 24, 24. I'm going to go 12 here. Just, I probably won't use that there, but I can go 12 on that. Click accept. I've got my chamfer tool created. Click enter there. Good to go on that. I got my geometry selected here. I'm going to go about selecting my chamfer width here. I'm going to use a chamfer width of 0.03, and then tip offset should be good there, clearance should be good there. So let's just click, turn smoothing on, click OK, see what we got here, and then you can see when it goes about the verification process here, it's going to leave, you're going to have a little bit of area right here where you can see where it has cut a chamfer into my workpiece there. So that's going to be perfectly fine for what we're doing there. Perfect acceptable. Okay, so now I'm to the point of having a program. I started this at 3:13. I'm at 3:31 right now. So that's 17, is that 18 minutes so far? Let's see. I believe it's at 18 minutes so far. Let's see where I'm at there. Yep, right at 18 minutes right now. So that's where I'm going to leave this at for right now. Well, actually, first I got to post this. Let's post it before we do anything else. So I'm going to click up here on my post process. I'm going to, they've changed this as I used it last, so I'm learning this right here right now for the first time. I'm going to click on my setup here, click OK, and then go back to post process again here. I have not used that since they've changed it, so that's a new one for me. Okay, so let's try this again here. Click on setup, click on post process here, and I want to select my machine right here. So let's go to my choose from library. So I want to go to Haas, because it's going to be for the Haas. And we got it's a next gen controller here. So next gen control here, click select. Go down and check everything looks good there. Like I said, this is different here from what we've had in the past, so looks pretty good there. Program number's okay. I'm going to use that program, that's fine for that. And I'm going to click open file in NC editor, and then click OK here. And actually I click post on that. Yes on that. And should have a program here. Now one thing I do want to do, I do want to probe this to look at this. And that's something I can actually do inside of the system here. Okay, so what I'm going to do is let's go up here and let's go to, let's see, to setup here, probe WCS. Okay. Select my tool here, and I think I have our probe built for this. If I don't, that's going to slow me down a lot. Yeah, here's our probe for the machine. And I'm going to pick on the probe the stock here. It's going to probe the stock surface here. And I want to check my Z surface right there. Approach, that should all be good there. All that should be fine. Click OK. I'm going to drag this up to the front so it does at the beginning of the operation. And then I'm going to do that again. And I'm going to do the outside of it. So once again, I select my tool, probe, select, and then geometry. I'm going to go to stock again, and I'm going to select my area there. And this will work perfectly fine for what I'm going to do there. So that actually works perfect for there. Click OK. Once again, drag this one up to the top. I'm going to do this second after it probes this second. After it probes the top surface, I'm going to probe the rest of it there. Everything regenerates here. So let's repost this. Overwrite the file I just wrote. And I've got it. So once again, here is my program. I am at 21 minutes, 21, 22 minutes right now. So that'll give you an idea about how much time it actually would take. Going relatively fast to program this on a CAD CAM system. Pretty simple part, not the most complex part. Can I beat it on the Mazatrol? Let's see.